Chapter 8 Summary. Binary Notation. Binary notation refers to the fact that computers communicate in 1s and poses or seconds. Positional notation is converting binary to decimal requires an understanding of the mathematical basis of a numbering system. This figure shows the positional notation. Network portion and host portion of an IPv4 address. To define the network and host portion of an address, a device uses a separate 32-bit pattern called a subnet mask. The subnet mask does not actually contain the network or host portion on an IPv4 address. It just says where to look for this portion in a given IPv4 address, as shown in this figure. Unicast transmission. In an IPv4, the host can communicate one of three different ways, which is unicast, broadcast, and multicast. The first one is unicast, the process of sending a packet from one host to an individual host, as shown in this figure. Broadcast transmission. The second one is broadcast, the process of sending a packet from one host to all hosts in the network. Note, routers do not forward a limited broadcast. Directed broadcast. The destination has 172.16.4.255 and host within the network has 1.2.16.4.0 and has prefix of 24 network. The third one is multicast. The process of sending a packet from one host to a selected group of hosts, possibly in different networks. It reduces traffic. It reserved for addressing multicast groups, which is 224.0.0 to 239.255.255.255. Link local. It has 224.0.0.0 to 224.0.0.255. The examples are routing information exchange by routing protocols. It is globally scoped addresses, which is 224.0.1.0 to 238.255.255.255. The example is 224.0.1.1 has been reserved for network time protocol. Public and private IPv4 addresses. Private address blocks are hosts that do not require access to the internet can use private addresses, which is 10.0.0.0 to 10.255.255.2.5 or 10.0.0.0 and has prefix of 8. 172.16.00 to 172.31.255.255 or 172.16.0.0 and has the prefix of 12. 192.168.0.0 to 192.168.255.255 or 192.168.0.0 and has a prefix of 16. Shared address is based on the addresses. It is not globally routable. It is intended only for use in service provider networks. It is address blocked in 100.64.0.0 and has a prefix of 10. Special use IPv4 addresses. Network and broadcast addresses. Within each network, the first and last addresses cannot be assigned to host. Loopback address, which is 127.0.1 is a special address that hosts to direct traffic to themselves. Link local address 169.254.0.0 to 169.254.255.255 address can be automatically assigned to the local host. Testnet addresses 192.0.2.0 and has a prefix of 24 is set aside for teaching and learning purposes, used in documentation and network examples. Experimental addresses 2.0.0.0 to 255.255.255.254 are listed as reserved. The net of IPv6. The need for IPv6. IPv6 is designed to be successor to IPv4. Depletion of IPv4 address space has been the motivating factor for moving to IPv6. Projections that all 5 RARs will run out of IPv4 addresses between 2015 and 2020. With an increasing internet population, a limited IPv4 address space issues with NAT and an Internet of Things, the time has come to begin the transition to IPv6. IPv4 has a theoretical maximum of 4.3 billion addresses plus private addresses in combination with NAT. IPv6 larger 128-bit address space provides for 340 undecillion addresses. IPv6 fixes the limitations of IPv6 and includes additional enhancements such as ICMPv6, hexadecimal number system. Hexadecimal is a base 16 system. Base 16 numbering system uses the number 0 to 9 and the letters A to F. 4 bits or half of a byte can be represented with a single hexadecimal value as shown in this figure. IPv6 address representation 1 to 8 bits in length and written as a string of hexadecimal values. In IPv6, a bit represents a single hexadecimal digit. 32 hexadecimal value is equal to IPv6 addresses. Hextent used to refer to a segment of 16 bits or 4 hexadecimals that it can be written in either lowercase or uppercase. IPv6 prefix length. IPv6 does not use the dotted decimal subnet mask. Prefix length indicates the network version of an IPv6 address using the following format. The first one is IPv6 address or prefix length. Prefix length can be ranged from 0 to 128 and the typical prefix length is /24 as shown in this figure. IPv6 unicast addresses. Unicast is uniquely identifies an interface on an IPv6 enabled device. A packet sent to a unicast address is received by the interface that is assigned that address as shown in this figure. Global unicast is similar to a public IPv4 address. It is globally unique. It is internet routable and addresses, and it can be configured statically or assigned dynamically. Link local is used to communicate with other devices on the same local link. It is confined to a single link. It is not routable beyond the link. Loopback used by the host to send a packet to itself and can be assigned to a physical interface. Ping an IPv6 loopback address to test the configuration of TCP or IP on the local host. All zeros except for the last bits represented as ::1/128 or just ::1. Unspecified address. All zeros address represented as ::/128 or just ::2. Cannot be assigned to an interface and is only used as a source address. An unspecified Specified address is used as a source address when the device does not yet have a permanent IPv6 address or when the source of the packet is irrelevant to the destination. The structure of an IPv6 global unicast. IPv6 global unicast addresses are globally unique and routable on the IPv6 internet. It is equivalent to public IPv4 addresses. ICANN allocates IPv6 address blocks defined RARs. Global unicast address has three parts: the global routing prefix, subnet ID, and interface ID. Global routing prefix is the prefix or network portion of the address assigned by the provider, such as an IP, the customer or site. Currently, RARs assigned as /24 global routing prefix to customer. Dynamic configuration of a global unicast address using SLAAC or Stateless Address Auto Configuration. It is a method that allows a device to obtain its prefix length, and default gateway for an IPv6 router. No DHCPv6 server needed. Rely on ICMPv6 router advertisement or RA messages. IPv6 routers is forwards IPv6 packets between networks. This can be with the static routes or a dynamic IPv6 routing protocol. It sends IPv6 RA messages. Dynamic link local address. Link local address. After a global unicast address is assigned to an interface, an IPv6 enabled device automatically generates its link local address. Must have a link local address that enables a device to communicate with other IPv6 enabled device on the same subnet. Uses the link local address of the local router for its default gateway IPv6 address. Routers exchange dynamic routing protocol messages using link local addresses. Routers routing tables use the link local address to identify the next hop router when forwarding an IPv6. Traceroute or testing the path. Traceroute generates a list of hops that were successfully reached along the path. It provides important verification and troubleshooting information. If the data reaches the destination, then the trace list is the interface of every router in the path between the hosts. The summary: IP addresses are hierarchical with the network, subnet network, and host portions. An IP address can be represent a complete network, a specific host, or the broadcast address of the network. The subnet mask or prefix is used to determine the network portion of an IPv6 IP address. Once implemented, an IP network needs to be tested to verify its connectivity and operational performance. DHCP enables the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration information. IPv4 hosts can communicate one of three different ways: the unicast, broadcast, and multicast. The depletion of IPv6 address space is the motivating factor for moving to IPv6. Each IPv6 address has 128 bits versus the 32 bits in an IPv4 address. The prefix length is used to indicate the network portion on IPv6 address using the following format: IPv6 address /prefix length. There are three types of IPv6 addresses: the unicast, multicast, and anycast. An IPv6 link local address enables the device to communicate with other IPv6 enabled device on the same link and only on that link, which is the subnet. Packet with a source or destination link local address cannot be routed beyond the link from the packet originated. IPv6 link local addresses are in the FEAT concurrent/time range. ICMP is available for both IPv4 and IPv6.